Hello, in this video we will discuss about classifier neural networks, or in more general terms a prediction model, and how to measure its performance using accuracy. So what is a prediction model? In machine learning, a prediction model F is simply a function that takes an input and outputs a prediction about the input. Now, in case of computer vision, the input is usually an image, which, when given to a prediction model F, the model can output something about the image, like what does the image contain. For example, in this case, it would just be a dog. Or if the image contains an object like dog, then the model can tell at which location in the image is the dog present by providing a bounding box around that object in the image. Or if we go in more details, the model can also tell exactly which pixels of the image correspond to the object. For example, in this case, it would be dog. So the prediction model can tell exactly which pixels are occupied by the dog by coloring those particular pixels in the red color. Now, if we discuss the problem of multi-class classification problem, it simply is that the model tells or model predicts the class of the image. For example, because this image contains dog class, so the class of this image is dog. Now, how can a prediction model be made to predict a class of an image? Now, what people generally do is that when they feed an image to the prediction model F, then they expect the model to output a multi-class vector, a fixed multi-class vector, where every index corresponds to a different class. For example, if the model has to output a dog class, then it would simply output a value 1 corresponding to the index of dog and a value 0 for every other index. So in this case, the dog class will have a value corresponding to it as 1, and all other classes will have values corresponding to them 0. Now, how to measure the performance of a classifier neural network or a prediction model? For example, if you are given a lot of prediction models, how will you decide which prediction model to use? So for this, what people generally do is they use a metric called accuracy. How is accuracy measured? So for this, people use a held out test data set which the model has not seen while it was being trained. We will come to training of prediction neural networks later on, but in a sense, the input of the prediction model is something that it has never seen before. Now, the prediction model makes some prediction y hat. For example, let's say if the image is ith image, then the prediction would be, let's say, y hat I. And we know from the human annotation the correct class of the image I, which let's say is yi. So in this example, the yi would be dog, and yi hat can also be dog. So in this case, the model is good. But we can't use just one image to measure the accuracy, right? Because it may happen that the model is good on this particular image, but it may not be good on some other image. So what people generally do is they consider a set of images. Now let's say if we pick a random jth image, if yj hat is same as yj, then we would be happy because the model makes the same prediction as the human annotated. But if yj hat is not same as yj, then it is not something that we would like. So we won't appreciate such a model. Now, given a set of images, To define accuracy, let's first define an indicator function. Indicator function yi hat equals yi is simply 1 if yi hat is yi and 0 otherwise. That is, if yi hat is not equal to yi. Now, to compute accuracy, we simply try to take, let's say, n test images. So, n images which the model has never seen before, and compute accuracy like sigma I equals to 1 to n. We are summing up the n indicator values, n indicator function values corresponding to each of the n images, where there would be value 1 where the model was correct and value 0 otherwise. For example, let's take a prediction model and run 10 images through it. So we are given a prediction model F which takes an ith image and gives a prediction yi hat. So in this case, the prediction y hat is is defined by the third column. The ground truth assigned by the human or annotated by the human is the correct class and is given by the second column. Now, how to measure the accuracy? Let's construct a fourth column which is just a indicator function value. It would be 1 in this case because dog is dog, cat is cat. So 1, elephant is not dog, 0, bus is bus, 1, kite is kite, 1, bottle is not cup, 0, dog is dog, 1, fork is fork, 1, cat is cat, 1, carrot is not fork, so 0. So how many values are 1? If we sum it up, we will get 7. So out of 10 images, the sum of the indicator function value is 7. So the accuracy in this case, which is simply 1 upon n, where n is the number of test images and summation is over all these test images, the indicator function values, which is yi hat and yi, it would be 7 out of 10, so it will just be 0.7. So in this case, we will say that for this particular prediction function f or a prediction model f, the accuracy is 0.7. Now, about training such a prediction model or how to optimize or train the model to have a good accuracy, indicator function is discontinuous. So optimizing directly over accuracy to maximize it is very inefficient, as indicator function value is either 1 or 0, so it's not differentiable, and we can't directly use the tools of convex optimization. So we optimize a proxy for accuracy. One of the most popular proxy is cross entropy loss, which we will discuss in another video.